So this question gives us an equation, and here it is, right? In the question, it's given. That's modeling the height of a basketball over time. What is the maximum height of the basketball? It gives you a hint. Complete the square to find the vertex. Okay. So we're going to skip that part, but you get something like this. It starts here, it goes up, and it comes down, and it hits the ground there, right? Parabolic relationship, quadratic relationship. And the maximum height occurs at the vertex. You complete the square to get the vertex. What is the horizontal distance of the basketball when it reaches its maximum height? So the maximum height is going to be the value on that axis, which is h. This axis is horizontal distance. So the horizontal distance when it reaches its maximum height, you would read off of the horizontal axis, or when you've completed the square, you've got that value found algebraically. So that's how you would do questions A and B. The question C, the one that we've asked about, at what horizontal distance is the ball 3 meters high, round to the nearest tenth? So we've talked this year about problem solving, and yes, this is a different kind of question. In fact, I don't think we've ever done anything quite like this. But what could you... So if you're given a question that you've never seen before, what do? You start, like, how do you proceed? Because this question has been given, which means your teacher believes it's reasonable for you to be able to work through it. Maybe not finding success. Maybe you try some things and you don't get it, and then you ask, and that's fine. But, hoping that with a little bit of extra effort, you might be able to get it. Well, let's write down the formula. Let's see. We're going to use one really common strategy that's going to help us solve this problem. So there's our equation, and it's got these two variables. H is the height, and D is the distance, the horizontal distance. It's very important, and this is something that a lot of people skip over and don't do, is really think about what those variables represent, what they mean, and to think about how this equation is relating those two variables. Given a particular distance, I can find the height. Given a particular height, I can find the distance, because they are related. Those two variables, height and distance, are related via that equation. And then I go back and reread at what horizontal distance, right? That's what that's saying. What is D? At what horizontal distance is the ball 3 meters high? So it's telling us what H is and asking us to find D. This is a little bit different from what we've done in this course. But we've done this in linear equations. You've done this in all kinds of other areas. So realizing that the question is giving you the height. It's telling you the value of H and asking you to find D. That's the step that I would hope people could get. So I've got this far. I don't know what to do next. I'm not sure how to do the actual algebra of this. And then you sub in. Again, that's something that's reasonable to do, even if you've never done it in this exact context. We've done that lots of other times. And then how do we solve any kind of equation? Well, we move everything to one side, set it equal to 0, and then we try to solve. So I am going to subtract 3 from both sides. And I get 0 on this side, which is what we want. And I get negative 0.09 d squared plus 0.9 d minus 1. Now I'm looking at this and I'm thinking it sure doesn't look like it's easily factorable. No reason to think that it would be factorable, even just looking at the question from the beginning. It's got all these decimals and it's a basketball. Why would it be a nice round answer at 3 meters high? I mean, could work out that way, and looking at this, it really doesn't look like it's going to factor. So I'm thinking quadratic formula. So I'm gonna punch it into my quadratic formula. Dot dot dot. Imagine that I did that. I get these two answers. It wants rounded to the nearest tenth. But what I'm going to do is give these answers to a little more decimal. So 1.273, and I get D is approximately 8.7267, so 7. The 6 rounds up to a 7. And that's unusual. Often with these quadratic questions, we get two answers, but one of them's negative, so it's no good. And we say inadmissible, and we cross it out. But this time I got two answers. What's happening here? Well, again, think about it. Think about what this is. If we did some more work with our graph, we would notice that the maximum height is bigger than 3 meters, and it starts at 2 meters. I know that from the equation right there, right? I could sub in 0 for D and I find 2, but the standard form gives me that value. So it starts at 2 meters. Maximum height is bigger than 3, so it's going to have to pass 3 meters on the way up and pass 3 meters on the way down. And clearly that's what's happening in our graph. Again, that's why graphing is so helpful. It helps us visualize what this and make sense of this answer. And so I've got two heights. The question doesn't say on the first one or the second one, or it doesn't say anything about on the way up or on the way down. So both of these answers would be fine. And then I would do my therefore statement. Therefore, the basketball is at 3 meters high after both 1.3 meters horizontally or 8.7 meters horizontally. 8.7 meters. Is it meters or is it feet? Yeah, meters. That seems a little odd, but anyway, that happens sometimes in these questions. Okay, so that's what question number C is getting at. It's a nice question. Lots of thinking going on there. Subbing in our value over here and solving, recognizing we need the quadratic equation. And then at the end, I really like this, thinking about there's these two answers, but interpreting that answer, right? That's where our understanding of how the graph and the situation and the equation, all of those things really come together to help us understand the final answer to this question.